Hi guys, myself Sachin. I'm from SVCE Bangalore, 4th SEM ISC. So we'll discuss about statistical methods and curve fitting. So next we'll see about introduction to statistical methods and curve fitting. Statistical methods are used to analyze data and make inference about population. Curve fitting is a technique used to find the best fitting curve for a set of data points. Understanding statistical methods and curve fitting is crucial for making accurate predictions and drawing meaningful conclusions from data. So next we'll see about importance of statistical methods. Statistical methods helps in summarizing and interpreting data. They provide a framework for making decisions based on evidence. Statistical methods enables research to generalize findings from a sample to a large population. So now we'll see about types of statistical methods. The first one is inferential statistics. Makes predictions or inference about a population based on a sample. The next one is descriptive statistics. Summarizes and describes about data using measures like mean, median and standard deviation. The third one is hypothesis testing. Determines the livelihood of an observed difference being due to change of a real effect. So we'll see about overview of curve fitting. Curve fitting is a mathematical approach to find the best fitting curve that represents a set of data points. It helps in understanding the relationship between variables and making predictions. Curve fitting involves in selecting a suitable model and estimating its parameters to minimize the difference between the model and the data. So now let's see about types of curve fitting model. The first one is linear regression. Fits a straight line to the data points. The second one is polynomial regression. Fits a polynomial curve to the data points. The third one is exponential regression. Fits an exponential curve to the data points. So now let's see about linear regression. Linear regression models the relationship between two variables using a straight line. It is commonly used when there is a linear relationship between the variables. The equation of linear regression model is y equals mx plus c, where y is an dependent variable and x is an independent variable. M is the slope and the c is an intercept. So next we'll see about polynomial regression. Polynomial regression models the relationship between two variables using a polynomial curve. It is used when the relationship between the variables is nonlinear. The equation of polynomial regression model is y equals ax plus bx plus cx square plus dx cube, where y is an dependent variable and x is an independent variable and a, b, c, d are the coefficients. So next we'll see about exponential regression. Exponential regression models the relationship between two variables using an exponential curve. It is used when the dependent variable increases and decreases exponentially with the independent variable. The equation of an exponential regression model is y equals ax square x, where y is the dependent variable and x is an independent variable, where a is an initial value and b is a growth or decaying factor. So now let's see about nonlinear regression. Nonlinear regression models the relationship between two variables using a nonlinear function. It is used when there is no specific form of relationship between the variables. The equation of nonlinear regression depends on the chosen function and its parameters. Let's see about steps in curve fitting. Identify the types of relationship between the variables. Select an appropriate curve fitting model. Estimate the parameters of the model using statistical methods. So let's see about goodness of fit. The first point is R squared. Measures the proportion of variance in the dependent variable explained by the model. The second point is residual analysis. Examines the difference between the observed and predicted values. The third point is a high R squared value and small residual indicates a good fit. We'll see about consideration in curve fitting. The first one is overfitting. Fitting the data too closely leads to poor generalization. The second one is underfitting. fitting the data too loosely, failing to capture the underlying relationship. Balancing the complexity and simplicity is important for accurate curve fitting. So, we'll see about common challenges in curve fitting. The first one is outliers, extreme data points that can significantly affect the fit. The second one is nonlinear relationship, difficult to model accurately without prior knowledge. The third one is multicollinearity, high correlation between independent variables which can impact parameter estimation. So let's see about tools and software for curve fitting. The first one is statistical software. Packages like R, Python and MATLAB provides built-in functions for curve fitting. The second one is Excel also have curve fitting capabilities through its regression analysis tool. The third one is various online curve fitting calculators are available for quick analysis. Let's see about applications of statistical methods and curve fitting. The first one is economics, forecasting economics trends and analyzing market data. The second one is engineering, modeling system behavior and optimizing designs. The third one is healthcare, predicting disease and progression and analyzing patients' data. At last, the conclusion. Statistical methods and curve fitting are essential tools for analyzing data and making predictions. They help us in understanding relationships between variables and making informed decisions. With the right approach and consideration, curve fitting can also provide valuable insights and accurate predictions. Thank you guys. We'll see in the next session.